Today we discuss non-restoring division for unsigned integer. So, what is non-restoring division? Actually, here if perform the non-restoring division, it is less complex than the restoring one because simpler operations are involved here in case of non-restoring operations, and that is addition and subtraction will follow. And in this method, we rely on the sign bit of the register which initially contains 0 named as A, that is the register bit. So now we describe the non-restoring mechanism stepwise. So at the initial stage, first the register, that is A, will be 0. Next, what is the Q? Q is the divisor, Q is the dividend, and what is the M? M is the divisor. Okay. So initially we set the values. First of all, Q that is given, that is dividend, and M also given, that is divisor, and A initially register set 0, and we know n is the number of bits in the dividend. Okay. Now in next step 2, that is first we check the sign bit of the register A. We check the sign bit of the register A. This is very important. Okay. Why? Because if it is 1, if the sign bit is 1, that is negative. If the sign bit of A is 1, then shift left content of the AQ means A and Q, and we perform A is equal to A plus M if it is 1. Otherwise, shift left AQ and perform A is equal to A minus M, that is add 2's complement of M to A and store it into the A. Okay. So if it is 1, then we perform the shift left content operation and A is equal to A plus M. If it is not 1, that is 0, then we perform A is equal to A minus M. That means we add the 2's complement of M with A and we store it into A. Again, the sign bit of the register A is there. Next, in step number 5, if sign bit is 1, then Q0 becomes 0, and if sign bit is 0, then Q0 will become 1. Okay. If sign bit is 1, then Q0 becomes 0. Otherwise, Q0 becomes 1. Q0 means the least significant bit of the register Q. Okay. Next, we decrement the value of n by 1. That is n is equal to n minus 1. And the last step, that is step number 7. If n is not equal to 0, go to step number 2. Otherwise, we go to the next step. That is, if the sign bit of the A is 1, then perform A is equal to A plus N. Or in step number 9, the register Q contains the quotient and A is containing the remainder. Okay. So we start this non-restoring algorithm with an example. So we perform here non-restoring division for unsigned integer. Say here dividend Q is equal to 11 and say divisor M is equal to 3. Okay. Dividend Q is equal to say 11 and divisor M is equal to say 3. And initially we do the 2's complement of M, that is 11101. Okay. So let us start the problem. What is the basic mechanism of calculation of the non-restoring division method algorithm? So initially, what is the value of M? That is 3. So we convert it into 5 bits. That is 0, 0, 0, 1, 1. That is 3. And what is A? That is 5-bit digit. Initially, we make all the values 0. So 0, 0, 0, 0, 0. And what is Q? That is 11. That is 4-bit digit 1, 0, 1, 1. Therefore, the value of N is 4 because here we consider 4 bits. So in the second step, we shift left. So therefore, this 0 will come here. This 0 also will come here. This 0 come here, and this 0 will come here. And from here will come here. Here 1 will come here. Okay. So this bit is 0, 0, 0, 0, 1. And here the bits are 0, 1, 1. And the initial bit of the Q0 is 0. Means empty. Okay. So what is the procedure? So here the most significant bit of the A is 0. Therefore, we perform A is equal to A minus M. So A is equal to A minus M means here we know the value of A, that is 0, 0, 0, 0, 1. And what is minus M? That is 2's complement of M. That is minus M means the 2's complement of M. So now we add this both a and a plus minus m. That is 1 plus 1 0, 0 0, 1 plus 1 0, carry 1. So that is 1. This also 1, this also 1, and this also 1. So the value will become 1 1 1 1 0. Okay, and this is 0 1 1. Now if the most significant bit of the a minus m value is 1, then q0 is set to 0. That is for negative number. Q0 is set to 0. Therefore, if it is 1, then it is 0. Okay. Next, we go to the next step. That is, again we shift left. That is, this one come here, this one come here, and this one also come here. This 0 is here, and this 0 will come here, and here is only 0 0 1, and this field is empty. The initial bit of the Q is empty here. So again, this is 1. If it is 1, then we operate what operation? If it is 1, then we operate a is equal to a plus m. So what is the value of a here? That is 1 1 1 0 0. And what is the m? We know that is 0 0 0 1 1. So value will become 1 1 1 1 1. So we write here 1 1 1 1. And this value will become 1 1 0. And this bit is empty. Okay. So if the value, most significant bit of the a is 1, then we told this value is 0. So the q0, that is the initial value, that is the first value, first bit of the q will be 0. If the most significant bit of a is 1, that is negative. So this value will become what? 1 1 0 0. Okay. Next, again we shift these values. That is, here 1 will be here, this one will be here, this one will be here, this one will be here, and from 1 it will come here. And this is only 1 0 0, and this bit is empty. Again, we start the procedure. That is, this is 1. If it is 1, then we start a is equal to a plus m. If we add this a with the value m, that is 0 0 0 1 1, then we got 0 0 0 1 0. 0 0 0 1 0. Okay. And this is 1 0 0. And if it we know if the value is here 0. Okay. So here this is 0 0 0 1 1. The previous value 0 0 0 1 1. And what is the initial value of this value? Say if it is 1, if the value is 1, then here what happened? That is, q0 will be 1. If it is 0, that means here this value is how much? This value is 0 0 0 1 0, and this is 1 0 0. So what is the most significant bit of a now? The most significant bit of a now is 0. If it is 0, then this field is filled up with 1. That is positive value. If the most significant bit of a is 0, then the initial bit of the q will be replaced as 1. Therefore, in the next step, it will be 0 0 0 1 0, and it will be 1 0 0 1. So it is 0 0 0 1 0, and it will be 1 0 0 1, and here q0 is equal to 1. Okay. Again, this is 0. If it is 0, we know, again we shift left first of all. So this 0 will come here, this 0 will come here, this 1 will come here, this 0 will come here, and this 1 will come here, and this is 0 0 1. Okay. And this is empty bit. This is basically the empty bit. Then what happened? Then we check what is the most significant bit of a. That is 0. If it is 0, then we perform a is equal to a minus m. Therefore, we a minus m. Actually, what happened? We add a with the 2's complement of m that are shown in the previous slide, and the result will become 0 0 0 1 0. Okay, and this will become how much? 0 0 1. Got it? Now this is 0. If it is 0, then what happened? If it is 0, then the initial bit of the q will be 1. So it is 1 here. Therefore, this is 0 0 0 1 0, and this is 0 0 1 1. This is basically the last iteration. Actually, now the count becomes 0. Therefore, we finish the process here, and what will be the result? The quotient will be 3. This is basically the value of quotient. Okay, that is q value. Quotient value, that is 0 0 1 1, that is 3. So the quotient is 3, and what is the remainder that is stored in the a? That is 0 0 0 1 0, that is 2. So the basic answer of division 11 divided by 3 is quotient is 3 and remainder is 2.